Hello and welcome back. In the last video we did an example where we showed how we can sketch a parabola by converting its equation in standard form to an equation in factored form. We established how the factored form gave us the x-intercepts or the roots, and once we did that we were able to find the vertex and therefore sketch the parabola. So in the last video that example was with a simple trinomial, and in this video we're going to do that example with a complex trinomial. In this case our complex trinomial will be y is equal to 2x squared minus 7x plus 3. And the first thing we're going to do is factor it using decomposition in order to convert it to factored form. So as normal we would multiply the first number by the third number. That would give us 2 times 3 or 6. And we need two numbers that add up to negative 7 and multiply to give us 6. So negative 1 and negative 6 we know add up to negative 7. If we multiply those two numbers we get 6. So we know that works, right? They add up to negative 7 and they multiply to 6. So those are the two numbers that we need. So we can go ahead and rewrite our equation as 2x squared minus 6x plus negative 1x plus 3. We will then put brackets around the first two terms and brackets around the last two terms. The common factor in 2x squared minus 6x is 2x, so we can factor that out to get 2x times x minus 3. And the common factor in negative 1x plus 3 is negative 1, so we can factor that out. And we'll have negative 1 times x minus 3. Now of course plus negative 1 is just subtract 1. So we can do minus 1 times x minus 3. The common factor in that expression is the x minus 3, so I will color code that. And then we can factor out the x minus 3 to get x minus 3 times 2x minus 1. So that is our equation in factored form. So I will just rewrite that again over here. And just as before, we will use our equation to find the x-intercepts of the parabola by setting y is equal to 0, because we know that the x-intercepts are located on the x-axis. And at that location we have that y is equal to 0. So in order for that equation to be satisfied, we need to have that either x minus 3 is equal to 0, or that 2x minus 1 is equal to 0. In order to have that x minus 3 is equal to 0, we would need that x is equal to 3. What about 2x minus 1 is equal to 0? Well, in order for that equation to be equal to 0, or that expression to be equal to 0, it is not as clear what we would need x to be. So we will use these skills from the last playlist of solving linear equations in order to find that x value. So I will rewrite that again over here, and we will solve for x the way we normally would. So the first thing to do would be to get rid of that negative 1. In order to do that we would add 1 to that side. Whatever we do to the left side of the equation we do to the right side of the equation. So if I add 1 to the left hand side, that means I have to add 1 to the right hand side. Negative 1 and plus 1 will cancel out, and I will be left with 2x is equal to 0 plus 1, or 2x is equal to 1. Finally, to get rid of the 2, I would divide the left hand side by 2. That means I would have to divide the right hand side by 2. The 2's cancel out, and I'm left with x is equal to 1 over 2. So there you have it. In order for 2x minus 1 to be equal to 0, we would need x to be equal to 1 over 2. And just to check, if we plug x is equal to 1 over 2 into the equation 2x minus 1, we'll have 2 times 1 over 2 minus 1. The 2's would cancel out and we would have 1 minus 1 or 0. So we know that that x value is the correct x value. So we have established that the x-intercepts are located at x is equal to 1 over 2 and x is equal to 3. So we can plot those 2 points on the graph. Here once again we have that the x-intercepts are 1 over 2, 0, and 3, 0. And just as before, we established that for a parabola, if we have 2 points at an equal height, we can find the vertex by finding the midpoint in between those 2 points. Now again, here it might not be as clear what the midpoint is, but once again we can treat it as an average value. So we can take 1/2, or 0.5, plus 3 and divide that by 2. So in that case we're summing the two values and dividing that by the number of values. That is how we would calculate an average. and we would have 3.5 divided by 2, or 1.75. So we have that the vertex is located at x is equal to 1.75. So I can plug that into the quadratic equation. I will have y is equal to 2 times 1.75 squared minus 7 times 1.75 plus 3. And that will give me y is equal to negative 3.12. So the vertex is therefore located at 1.75, negative 3.12. I can plot that value on the graph and then connect the points to find our parabola. So there you have it. That is the graph of the parabola. Again, we were able to use the factored form to find the x-intercepts and then the vertex, and that gave us a really good idea of what the parabola looks like. So that's all I wanted to do for this video. In the next video, we'll be looking at the quadratic formula, which is another method of finding the x-intercepts or roots of a parabola. But for now, as always, thanks for watching.